I'm just going to rudely point you at the screen for a couple of minutes while I go and wash my face, because I'm still sort of dressed as a badger because of the Lego story show that we just did. And I will return. You're in a new place. Can you tell you're in a new place? We're going to do an activity in a new place, and then we'll go back up to my office and we'll do normal science learning stuff. I won't go down. Hello! You are actually in my downstairs toilet at the moment, which is the only place with a mirror. So I'm here to check whether my badger nose has been washed off my face. But you know what? Oh, we'll get started. Yes, let's do this. Right, shut this door so that none of my family members come in and get horribly freaked out. Okay, I'm going to do this. Let's flip you around. Yeah, you ready? This is really weird. Okay. Hello, Science Alliance. Hello. Welcome. This is our IGCSE physics lesson about lenses. It's actually one of my favourite lessons that I teach, if not the favourite IGCSE lesson that I teach, because of this activity that I'm about to show you. We're in my downstairs toilet. We're not going to be here the whole time, but I needed to take you somewhere where it could be completely dark, because we're going to look today at how lenses work. We're going to draw some diagrams to help us predict how lenses work. But yeah, before that, I thought we'll see them in action. So I've got a magnifying glass here, and you might be like, I know how magnifying glasses work. Yes, I know you do. I know you think you do. I used to think I knew how magnifying glasses work as well. They magnify things, don't they? They make them bigger. That is what they do. That's one of the things that they do. So you can't see it really well, but hopefully you can tell that if I stand on the opposite side of this magnifying glass that this candle is, then it's making the candle seem bigger. Yeah, we all know that happens. Okay, but I'm going to light this candle now. And on the other side, so the same side as a magnifying glass, I've got a screen here on the opposite side of the magnifying glass to the candle. And what I'm going to do is, I'm going to turn the lights off so that we can see the candle better. And then move the magnifying glass away from the candle whilst pointing you at the screen, because that's where the fun's going to happen. Okay, you could totally do that. You have to. If you've got a magnifying glass and somewhere that's dark in your home, you have to try this. It's really cool. Do you know what's going to happen? Candle here, magnifying glass here, white screen on the other side. I'll turn the lights off. And all I'm going to be doing is moving the magnifying glass away from this candle whilst pointing you at this screen. So what are we seeing? Well, there's light, right, on the wall. So we know that light is travelling through the magnifying glass, but we haven't got an image or anything. It's just kind of random light rays hitting the wall. But if I move the magnifying glass closer and closer to the screen, whoa, can you see that? I just love this. I don't know if it's coming across quite as well on screen as it is in real life, but if I zoom you in, tell what that is if I blow it. It's a massive upside down candle on my screen. Just a bit of paper stuck to the wall. You see that? So if I move the magnifying glass further and closer away, it goes in and out of focus. What is that about? So what we're doing today is we're talking about why that happens, but that's not the only thing that you can do. I want to get it Just trying to get it like really nicely in focus for you. Anyway, I'll show you the other thing you can do. If I keep moving the magnifying glass closer and closer. So nice. Yeah, okay, so let's zoom you back. Keep looking at the screen. I'm just going to be moving the magnifying glass further towards the screen now. So it goes out of focus. We'll talk about why that happens. It's kind of like a searchlight now. That's a clue for later. Thank you for liking. Don't forget to like and subscribe. That's right. I'm keeping moving. I'm keeping moving. Keeping moving. What are you expecting? Probably don't know what to expect. Oh, it's a teeny tiny little image of the candle. Can you see that? What on earth is going on there? Love it. So anyway, let's go back up to the regular normal office where I teach my lessons from and talk about why on earth that happens. Right, yes, come with me. I just need all this stuff. I'm going to cover up the screen because nobody needs to see the inside of my house. Oh, wait. No, I'm holding things and I can't open the door. So smooth. Ugh. Right. Door is open. Got my laptop. Okay, come on, we must do learning. Have you got a piece of A4 paper? You need a piece of A4 paper. And if you like, if you can hear me, you can start folding it up 3 times. You need to fold a piece of paper up 3 times. Fold it once, twice, 3 times. Well, you actually need to do that twice. Along the short edge and the long edge. If you want a head start, right, flip you around. Here we are, back to learning. It hasn't gone weird, has it? I thought the audio and the visual had gone a little bit out of sync. I think it's okay. Yes, can you please get a piece of A4 paper? It can't be scrap, unlike a lot of the activities we do. It has to just be a pristine sheet. And can you fold it in half 3 times along the short edge? So you end up with, when you fold it out again, you end up with 8 rectangles in a row. We're making ourselves some squared paper because that is a super cool activity, which I only eventually worked out you could do. It's really silly. There's this, like, IGCSE and regular GCSE as well, you teach about lenses. And there's a whole lesson that I did, which you're about to do as a physics teacher, where you look at how lenses work. And I taught it loads of times before I suddenly thought, wait, that's just a magnifying glass lens. You must be able to actually do that, and then made it in real life and couldn't believe it. So you need 8 rectangles separated by creases on a bit of paper. Yeah, and when you've done that, can you do the same thing again in the other direction so that we've made some squared paper? And we're going to use that to draw our diagrams on. I've said this quite a few times. Some of you will know, some of you won't. If these lessons are obviously, you can just watch them for fun. You don't have to do an IGCSE physics lesson, exam. But if you are doing IGCSE physics, there's 2 companies that could possibly write your paper. There's Cambridge and there's Edexcel. And most of the time, they both want you to learn about the same stuff. So it doesn't really matter right now. If you need to know before you do the exam who has written your exam paper. How it would work is if you wanted to do IGCSE physics, if you're in the UK where I am, you would find your local exam centre, if you're home educating. If you go to school, they sort it for you. But if you find your local exam centre, they'll say, oh yeah, we do the Cambridge exam. And then you'd have to go away and make sure you've revised everything that the Cambridge exam wanted you to revise. In most of these lessons, we're just talking about stuff that is in both exams and it's fine. The whole of lenses is actually only in the Cambridge exam. So if you know right now that you're doing the Edexcel Pearson exam, you don't need to learn this stuff. You get to learn it just because it's cool and interesting. But it is on the Cambridge specification. Okay, right, so hopefully you've done that and we've got some squared paper that we can play with. Let's do another little activity, because we did this when we did our aquariums lesson in the last all ages lesson. That's quite a nice little activity. So if you've done that, if you caught up with me, you need some kind of waterproof packaging. It really doesn't matter what it is. I said some plastic from the recycling. I've got this old almond milk carton. Just put a drop of water onto the writing on your plastic or whatever waterproof carton and see what happens. I mean, again, it's not rocket science. You probably know what's going to happen, but I'm going to show you anyway, because this is theatre of science and we're all about the household activities, aren't we? So, waterproof thing with writing on, drop of water from my glass of water, put the drop of water onto the writing. What am I going to see? Gasp! It's got bigger, hasn't it? The writing has got bigger. The writing has in fact been magnified. That's quite a good effect, isn't it? It's definitely magnified. Why does that happen? That's cool. You can even see the printing dots. Why does that happen? That's what we're talking about today.